Let's look at the function based and how to use the new keyword. So we are going to try to replicate this same object in a function-based format. Then we will discuss how to use the new keyword to instantiate an object. When I say instantiate, it simply means creating that object. Creating a piece of a set of objects that you have declared. You want to create instance of it. So let's comment this ones. So you see here, you have your car. So we're going to try to replicate this. Let's see. All right, so when you want to use function-based to create your object, you start with the keyword function because it's a function. So every rule that you have when creating a function follows. The difference here is that it's always advisable to start such function with a capital letter because you're going to use it as an object. So we say car. Let's comment this one for now. So you say car, then followed by the parentheses and the code block. So as this is, it's your normal function. There's no difference. So here, you see that our car has a name, color, and model. Remember what I told us about how to use this dot. This, in this case, references the object in question. The same, inside the function base, you can also use this dot name, then you assign the name of the car. And this here is also referencing the object. Is referencing this object that we are creating. This dot color equals to white. I'm just trying to replicate what we have above. Model equals to 400. Now we have a function. You will do it the same way. This dot start equals to function. The same syntax, no difference. The only difference is that this one is key value. For this one, you define it like a variable. Then you assign using the assignment operator. So this is also a function. And in this case, our function simply prints this and return started. So the same, the way you treat functions, the same you can treat it here also. So we can also define the stop. This is the second method. And we print this. The same, this one can also take parameters. And we can also implement the change name the same way, no difference. And we can also set values within this function to set name. So this we put name as a parameter, and we can also set the weight just like we did before. Now, this is a function-based object, and this is the static based. And this static here is the same, exactly the same with this right now. The only difference is that for us to use this function-based class or object, we need to instantiate it in order to reference it as an object. I will show you what I mean. If I just do car and call it as a function, there will be no problem. It's going to run fine because it's a function. And everything that is defined within this code block is a valid JavaScript statement. If I put inside this function console.log construct, if I run this code, you see that construct was printed because I called this code as a function. Now, remember our function is not returning anything. So if we say var car equals to car like this, there's nothing inside our car. Our car, console log car, our car is going to be undefined because this function does not return anything. And thereby, we cannot access all these properties that we have set if we do it like this. And here is where the new keyword come into play. When we want to instantiate this object, in order for it to behave like the same way this static one behaves, we have to use the new keyword to instantiate that object. So if we do new car, now if we run this code, remember that our car was undefined when we didn't add the new keyword, and the construct was executed quite all right. So if we run this using the new keyword, you see the difference. The construct function was still executed, and secondly, our car variable is no longer undefined, but a car object. A car object that has all the property that we have defined inside of it. You see the start, the stop, and the change name is here telling us that is a function. You can see all the property we set are all there. The same thing if we open this one, for example. And because we have this thing, so let's change this one to car 2. Because we have car here. So if we console log this one, console.log car, this is the first one. This is, let's put it there so you recognize it. Car 1. If we run this, you see that car 1 is an object that has all these properties. Now, you see this one is also the same object and it has the same property. You see, start is a function. You see, start is a function here. And you see all these attributes and you can see them here. Everything is the same. There is one thing that is different though. Remember I told you that this one is static. For example, I cannot do new of this. It's going to throw an error. So if I do something like new car, I can't do this with this particular method, this one. I can't. So if you run this, you're going to get an error. You can't do this with the static one. This static one means that you cannot create an instance from it. But with the function base, you can create an instance of this, which means with one object, you can create multiple cars with different property and the same method, of course, but the same method, the same property, but with different values. So with this one, you can use the new keyword to create an instance. So this is car 2. We can also create another car 3, and we will use the same car instance, the same car object that we have created. And if we car 3 and we print this out, you will see your car 2 and car 3 having the same object, Now, I told you that there is a difference between this and this one. That difference, if you look at in the console, you see that after the car 1, there is no anything before this object. But you see this one, car 2, it gives us the name of the object's parent. That is the parent object, the name is showing there. It's saying car. This is like the object name. So that is a little difference you are seeing there, telling you that this one is an instance of a car. But this one is no instance of anything. It's just an object, a static object. So that is one benefit of using the function based. One benefit. This ones, once you've defined it, you've defined it. You can change the values if you like, but you cannot make a copy of it. But in this syntax, you can use the new keyword to create an instance. And you can create as many times as you want. And in this case, our car 2 can become, for example, we can change our car2.name to become golf. And our car3, we can change our car3 name to become Toyota. And if we run this, you see that this one is golf, car2, and car3, this one is Toyota. But they are both an instance of a car. You can see this does not change. They are both an instance of a car, but they have different value inside. So what happened here, you see this construct is called a constructor. Constructor is the first function that is called when you create a new instance of a class or an object. So in this function based, whatever that is at this first code block is what is used to construct the object. So in other words, you can pass parameters here and it's going to use it to configure the object at the starting point. So if we say we pass name here and color, we can also set, instead of hard coding the name, we set the name that was passed to the constructor or the color. So this one can be hard coded, which means any car that you instantiate will always be model 400 until you change it using this format. So in this case, instead of doing this second one, we can just pass in the name of the car that we are instantiating here and the color that we want, black. And this one, we call it Toyota. And maybe color red. If we print this, you get the same behavior. It assigns the name and the color black and our Toyota with a color of red. So this function, this initial code block here is the constructor method. This is where you have to set your initial state of the object. And that is why these constructs always get executed. Remember that it's not this console that is printing that is calling the construct. The constructor is executed the first time you run new keyword with the object name. It's going to execute immediately. So if I run this, you see, let me comment this one. If I execute this, you see that constructor was called twice, which is because we instantiated it twice. All right. So each of these, you can call all this method that is inside, and they all act independently. So if I say car2 dot start, if I run this, you see start a car executed. And this one, start a car, did not execute because we did not call the start method yet. So for the car3, we can decide to change the name, and we call it Corolla, for example. So if I come here before the change of name and log what the name was before, name before, we call it car2, no, car3.name. So let's do this after, and you will see what the name is when we call change name. Remember, our change name method simply sets the name with a new name and changes the weight. So if we run this, you see that name before is Toyota, name after is now Corolla. So with this method, we can use it to modify the property. Now, if you check car2, if we come down here and we log our car2 remains unchanged, car2.name. You see, car2.name is still golf, which means these two objects are independent of each other, even though they are using the same object to instantiate both. That is the beauty of the function-based object. I guess this is clear. So remember I mentioned a constructor. You will not get the picture here unless we do a class-based one. Then you know, you see what a constructor function should actually look like. This one combines it together. So let's quickly do it, the class keyword, and we finalize for objects. This one is going to be very fast. So when you want to do class-based objects, you start with the class keyword. Again, we are going to replicate exactly the same thing, the same object again, car. Because it's a class, it's ideal to start with a capital letter also, just like what you did for function-based. Okay, so when you want to define a class, you start with class, the keyword, followed by the name of the class. Ideally, start it with capital letter, then followed by the code block. This is the syntax. Now, one interesting thing with class is that you have to provide it a constructor, because when you instantiate this class, like we did before, you need the first function that needs to execute to set up the object. This is not compulsory that you put it, but if you want to configure the class when it is instantiated, you need to provide it the constructor. And the constructor is actually an inbuilt function. So it's like a reserved word. You see that the color is blue, unlike the normal name that is always black. You see that it is blue, telling you that this constructor is a conventional syntax for class that we need to follow. So remember here, we pass in the parameter inside the parentheses of the function. The same thing that we did here, this is what you have to do in the constructor. So we want to set name and color when we are instantiating the car. You do the same. This dot name equals to the name in the parameter and this dot color equals to the color from the parameter. So you see, this we do now is exactly the same with what we did here, because this function serves as the constructor. So this code block is going to be the constructor. Look at the syntax: constructor followed by the parentheses. See the parentheses, then followed by the code block. It is exactly the same syntax with creating a function, but without the function keyword. Instead of starting with function, the name, you don't need to put in the keyword function. But this is a function. So let's say we want to instantiate this car, car1, we use the same new keyword, and we will call it exactly the same way we call the function base one. And we're going to pass it the name of the car and the color, let's say blue. So if we console log this car1, see what is there. You see the same way, this is an instance of a car, and this is the property that are inside. Remember, we've not added other methods. This is the only thing we have set, name and color, and you can see it right here. If you want to print the name, you do the same, .name. And if you run this, you get gov. The same with the color. If you want to add those methods, in this case, you don't need any these dots. You just have to follow this same syntax to define your method. Say start method. You see that this one is now color black instead of blue, because this one is a constructor method, which is an entry point when you instantiate your class. So this one is an ordinary method of the class, just like what we have here. So we can print or implement exactly the same thing like this. With your return, we'll do the same thing. And we can also implement all these second ones. And remember, the syntax is different. You don't need the function. You just have to call it the name, followed by the parentheses, and you're good to go. The same with this one too. You can do the same, and you're good to go. You see that we are also using this here, and this is also referencing the object. The object. They are all the same. So if we run this, you see it's the same. If we print the whole object, you see here, it's showing the property, but without the method. Like, unlike the other one, you normally show us that this thing has a method, but here is not showing. But that doesn't mean it doesn't exist. So if we call start, you see start a car is printed. And we can also change name exactly the same way we changed name before. Change name, and we pass in new name, Toyota. If we print what our car name is now, remember we set it to be golf before. Now is going to be Toyota. So this is class-based, the same object we defined, the same method we have applied, and you can see the behavior is the same. So it's either you use this format or you use the function-based format. But to instantiate it, you have to use the new keyword to instantiate the class. And the first function that is executed when you instantiate an object is the constructor method.